So I'll be very pleased to introduce Arnault here, who's going to talk about something that we should all be worried about, really. With all this great fizz and buzz about AI, there are huge problems, potential problems with bias, and a lot of people are thinking about how we can develop more ethical AI frameworks. So without further ado, Arnault.
Thank you very much, Charlie. Well, good afternoon, everyone. Thank you very much for attending, and thank you very much, Julien, for the opportunity to present today. So my name is Arnaud. I'm an NLP data scientist. I'm a bit an alien here, I think, because I'm not a specialist in semantic search. Nevertheless, I will try to fit a bit the bias identification and mitigation into the semantic search problem. So just a couple of sentences about me. So I've been working for 7 years in the industry. First, I was just like data scientist, and I specialized like 5 years ago on natural language processing. So I was saying, I've been working as a data scientist in the last 7 years, and specialized 5 years ago in natural language processing. Mainly, I've worked on industries just like educational tech, GovTech, MedTech, and lately I've been also a visiting lecturer at Barcelona School of Economics, teaching the advanced methods for natural language processing. And my main focus on research and also on the industry is few-shot learning, meaning how to adapt models and machine learning to new tasks with like a few or none example, and also multilingual problems. So we're going to come back to it later. And then everything related to ethical AI. So you have everything related to biases, mitigation of biases, but also robustness and test of your model when you deploy it and when you want to monitor it. Okay, so let's dive a bit into the problems of biases in AI. I have 3 examples I would like to highlight. The first one is the gender bias in lending. Basically, we saw a few results which are pretty important. The first one is that women got rejected more than men when they ask for a loan. Okay, so if you imagine that women and men who are just funding a startup and want to have some financing, generally women got rejected more than the woman. And when they got the loan, generally the amount volume is like lower than men, around $14,000 for the loan. And which is also interesting is when you look to the people who get into default, generally men have more default than women when they get the loan. So basically what we see is we identified false positive rates and false negative rates, meaning people who should have got the loans and who didn't get it, and people who got the loan and who finally got default. Generally, the women have there is a big impact on women because they didn't get the loan, and also even if they're less likely to go bankruptcy, bankers prefer to give the loan to men. So this is one of the example, and which is really important here is what are the metrics to identify this kind of bias. The second bias, I don't know if you're familiar with the Netflix documentary Code Bias. So if you didn't see it, I encourage you to take a look at it. And this is something that occurred in 2020 with the facial recognition models with a big racial bias, okay? Which is really thought-provoking is that IBM, Microsoft, Amazon, and other industries from the big techs, they were using this kind of recognition algorithm. And basically what happened, it's that the facial recognition was working pretty well for lighter-skinned human, like male, but when we go for a darker-skinned female, it has like an accuracy which were decreasing from 30%. So what does it mean? Basically, the algorithm works pretty well for lighter skinned people. And when you go for other people who were not into the training set, it didn't work so well. So the problem here generally was that the dataset was not balanced. And actually, I remember also another kind of bias on the same problem, which was trying to predict if someone's going to be a convict or not. And it was the other way around, meaning that darker skinned people were had a higher probability to be convict, even if there was like no other feature, than lighter skinned people, skinned individuals. So here again, we have a big impact into minorities and part of the population because of AI deployment. And so now we've seen something with lending, we've seen something with computer vision, and we're going to dive into something more focused on natural language processing. I imagine that you all know about ChatGPT and all the new multilanguage models, okay? And one of the biggest problem in natural language processing is the bias towards multilingual. What happens? Generally, the models work pretty well in English. But when it comes to other languages, such as Telugu, we're talking about Telugu, or I don't know, Urdu, or Tagalog, for instance, the results are pretty poor, like much poorer than for English. So yesterday, I just asked ChatGPT a really easy question just to give me 3 reasons to become a data scientist with 2 keywords. And the results are like quite obvious. So the English and French, basically it succeeds without any problem into giving 3 reasons with 2 words for each of the reasons. And when we go to Telugu, which is like a language spoken by 81 million people in India, we have only 2 answers, and the first answer is like quite weird. So this is an example of how the models can work pretty well in like high resource language and don't in other languages. And I think it's something that if you're working like in semantic search, you may face in every day. I will take, I think, the example of Wallapop. If the semantic search is working pretty well in Spanish, but not in Basque or not in Valencian or Catalan, I would imagine that it would be a problem for all the users and local users in those regions. So first, let's try to understand why there is like such a problem here today in natural language processing. If we take a look at the overview of multilanguage state-of-the-art by Sébastien Ruder, we see that there are more than 7,000 languages around the world, 400 languages with more than 1 million speakers, and 1,200 with more than 100,000 speakers. Nevertheless, we see that 70% of the research is focused only on English, okay? And actually, if you want to dive into like maybe 90% of the research paper are focused in English, Chinese, Russian, French, Spanish. So we're focusing maybe 9 out of 10 research models are focusing on 10 languages, which is a big problem. And moreover, it hasn't changed in the last 10 years because 10 years ago, the percentage was 63%. So we still are working on a lot, focusing on a few languages. And this chart actually highlights how much models, where you see all the models with GPT-3, T5, Lambda, were like trained for English, and you have several, like a few, which are trained with more than, in the training set, more languages than just the English one. Okay, so I think I think one of the focus, why it's really important to focus on the biases and such biases, for instance, on multilanguage in NLP, I think there are 3 types of reasons. First, you have ethical principle, and you just want to have like a uniform model for any language or for any population segment. Second, the problem of that I've highlighted just before is that your business is going to be impacted if it's work only for one type of population. If you want to scale to other population, you won't be able to do. So like on a business scale, you would need to have a robust model that can adapt to multi-language. And third, I would say that even if you don't care about ethical principle, even if business is focused on one language, in the end, there is a regulation that is coming. Like last year, they signed the EU AI Act, which basically asks you to have a risk-based approach about your AI systems. And now, I think in the coming month, I think they're going to be like more audit and more review about the AI systems that you deploy in your company. I highlighted 3 types of use cases which are considered as high risk. So the first one is essential private and public services. Basically, it comes back to the first example that we saw with the loans grantings. The second one is the law enforcement that may interfere with people's fundamental rights. So here we come back also to the second example with computer vision when we want to predict if someone is going to be a convict or not. And the third one, I think we can say that it fits a bit the semantic search case. Why? Let's imagine that you're LinkedIn. Okay, in LinkedIn you can just type down like a new post. Okay, if you want to find a new occupation, and basically, sorry. Okay, and basically, if you're a woman or if you're a minority and you don't have access to all the opportunities because of these kind of features, that means that you're going to avoid people to have access to every post, every occupation, and you're going maybe to strengthen the biases that are already existing. So for me, this is going to be like, they signed it last year, and it's going to be like a strict obligation to know about the robustness of your model and to know how to mitigate it. So now, concretely, what are the risks if you deploy like a non-robust multi-language model? I've mentioned non-robust and not only biased, because I think this can apply also to models which are going to decrease in performance in time because of data drift, not only because of biases. So the first one would be if you have like a non-robust multi-language model, the main risk is that you're going to strengthen the biases and force people to go along with existing biases. So if we come back to the example of LinkedIn, if we have like a sample of women who are just like nurses or working in like educational industry, and if you allow them only to see occupations related to those 2 industries, basically you're going to force them to keep on working on that and not giving them the opportunity to do other things. The second risk would be erase the cultural specificities. So this is more related to the multi-language problem. Because if your model are all in English, if I'm an Indian, if I'm South American, if I'm in Africa, I would have to adapt to the English language. I would have to adapt to English habits. And this is a problem because I'm a customer, I'm a user of your application, and actually I won't be able maybe to interact with your application. So the user is going to be, so you're going to uniformize actually all the habits around your users, which is something which is not really like desirable. Then the lack of generalization, if we focus on bias and ethical AI, it means that you cannot adapt to new languages, to new culture, to new, I don't know, to new population. And if you have this kind of problem, it's most likely that you have this type of problem also for your existing users. Meaning that if your model cannot generalize for new habits, it's most likely that if you have new novelties in your data set, like a big data drift, your model is not going to adapt also to. So the problem is that your model most likely is going to be out of service because it doesn't work in a few months. And finally, the risk about deploying this type of system is that you're going to benefit, the system is going to benefit only a tiny part of the population. If we take the example of ChatGPT, like everyone is saying, yeah, ChatGPT is going to make us increase our productivity, but only productivity in European and the North Americas. Because we saw that in Telugu, for instance, it doesn't have the abilities to answer me and to make automation about any chronophage task that I may have. So basically, if you're richer, you're going to increase your productivity. If you're poorer, it's most likely not. And obviously, the final problem would be your clients in the end are not going to be satisfied because from one day to another, there is a possibility that the search is not working anymore. Okay, so I think now you have like big idea about the ethical AI, biases, and this kind of stuff. So right now, I would like to dive into two chapters. The first one would be how to spot the robustness issues, and the second one would be how can we mitigate once we have identified these issues. Actually, it's like most of the work of the data scientist. Today, you see that, I don't know if you're familiar with scikit-learn, TensorFlow, Hugging Face, but it's really easy to deploy, it's really easy to train a model. Like it's the new Excel, I would say. But the main difficulty is, okay, how can I be sure that my model is going to work tomorrow? How can I be sure that my model doesn't have any bias? And how can I be sure that my model is going to be robust across time? So if you just conceptualize what is a model, a machine learning model, you have some inputs, you have a black box, a model, and then you have some outputs. In the case of spotting robustness issues, I would divide the methodologies in two. First, we're just going to consider the model as a black box, meaning we're not going to dive into the model. We're just going to take a look at the main at input and output and try to make some assumptions about a potential bias or potential default flows of the model. And the second one, and for this type of test, I would just highlight the two first one, which are performance test and metamorphic test. And for the third one, the last one, we're going to open the black box, okay, and we're going to look at a model as a sequence of layers which are taking some input and some output. And the output of the first layer is going to be the input of the second one. So this is basically the deep learning without getting into much detail. And from it, instead of looking at the final output, we're going to look at the output of each of the layers, okay? And we're going to try to identify the bias, not in the output, but in each of the layer to know what layer is creating this bias, is carrying the bias. So the first ones, so the most, the easier one, I would say, we saw on the second example that you had like a chart with results for lighter skin female, lighter skin male, darker skin male, and darker skin female. Basically, what you have to do is having a testing set with the characteristic of your population, for instance. It could be like different languages, it could be different population segments, and you're going to assess and to compute the quality of your metrics. Accuracy, scoring, F1, recall, precision, whatever it is. And you're just going to compare the result depending on those segments. And from it, you will be able to know if there is like a hint of bias in your AI system. This is something I did, like for instance, for Generalitat a few years ago, where we were looking at the impact of an NLP model on subsidies for the poorest people in Barcelona. And the objective was, okay, is there like a bias towards LGBTQ community? Is there like a bias towards women? Is there a bias towards Catalan-speaking people? And we saw just with this tiny analysis, we could spot a few problems, and we could like feedback this to improve the model. The second one is kind of linked. This is something I would call like adversarial attacks. It's not exactly adversarial attacks as you can see it generally in papers. The idea would be, okay, I have a training set, I have a testing set, I have my metrics, everything goes fine. I don't see any bias towards one type of population or one language. So what can I do to be sure that my model is robust enough to be deployed? One of the ideas would be, okay, we don't have a lot of label data, so we need to create the data to know if my model is really robust. So a few possibilities is just trying to modify slightly the input. For instance, if you have some entities such as firm names or countries or nationalities, you try to switch them by other nationalities or by other entities. If you have gendered pronouns, gender nouns, you're just going to switch them by another gender. And from that, you will take a look at the difference in probability between the outputs when you change the inputs. And actually, if there is like a huge gap between the probability in mean, it's most likely that your model like carries some biases. One really good also tool that I would mention is from a data visualization tool. Actually, there are two kinds, Lime and Chap. So I don't know if you're familiar with it, but this kind of visualization, which are non-technical at all, could help you out to understand why your what is the trigger of your output, meaning what word in your search had made this result. So you will understand that maybe if you have a sentence of 5 words, just one word really had an impact into the final results. And this is really like visual, so you can understand and see like some unrelated business relations between your output and your inputs. Okay, and now let's go into maybe the most complicated, but most likely the most interesting. So now we've seen inputs, outputs, and the model as a black box. Now let's try to slice this black box, the models, the AI systems, by layer. So I imagine like in semantic search, generally you have a final model representation and you want to fit it to a list of products. But before doing this scoring with the list of products, you have this representation. And with this representation, you can already see if there is some biases. Let's take an example with this totally random data set on the dashboard. So let's say that we have a search for sneakers on the top left, and we have a search for jerseys or t-shirts on the center. We could imagine that we have searches in 3 different languages, and actually we see directly that there is a problem of misalignment between the same search in 3 languages. So we have the same cluster, which is good, but we also see directly that our model is considering the feature of language too importantly compared to the final objective with the final product I would like to show my customer or my client. And so with this one, which is more experimental, you can create some distance metrics and try to find out which are the layers which are creating the final bias in your output. Okay, so now let's try to see some techniques about how to improve the robustness, how to mitigate the biases. Again, it's non-exhaustive. I mean, there are like a lot of techniques, but I think we could think about the techniques in 3 types, like pre-processing and data exploration, which means I'm going to spot some biases before I train my model. There is a second one, which is trying to avoid the biases during the training. We're not going to take a look at it, but just one quick word about it. It's like if you want to add some constraints during the training step of your model. And then the last one, which is like post-processing. So in this one, we already have trained our model. It's really costly to go to train against the model. So we would like to have a few solutions to try to mitigate the bias after we trained it. So we're going to try to post-process the output of our models to limit the bias, such as gender, racial, or multilanguage bias. So the first one, I think everyone already knows about it, would be balance a training set. We saw that, okay, we have like darker skin people with worse result than lighter skin people. We know that the data set is unbalanced. I already saw it in my exploratory data set, so let's try to balance it. The big problem with that, and that's why I mentioned it's utopian, is generally it's quite impossible to have a perfectly balanced data set. You don't have the data, it's pretty complicated to have, well, the same that with low language resource, like low resource languages, when you have some data, but you have like much less than for English, for instance. So you can try to quit every variables that could imply some bias, and you can try also to balance as much as you can, for instance, with ages, with genders, but it's most likely that at some point you're going to a dead end, meaning that at some point you cannot go beyond that. So if you don't have a balanced data set, there is a method which is called data augmentation, which is limited but can work to try to go beyond the balance of the balance of the data. What you can do is try to create new data for minorities. Like, let's say that we have a lot of a big training set with 75% of men and 25% of women. What you can try to do is, okay, which are the lines which basically the gender doesn't impact? Maybe we can just switch the gender pronouns, we can switch the gender nouns, and in this case, we're going to show to the final trainings, to the final model, to the trained model, that the gender doesn't have an impact. And in this case, we're going to kind of balance the final data set. For the multilanguage model, you can try the translation, which is also a good idea, but generally, if you do this kind of stuff, you're going to repeat a lot of features during your training step, and the problem that could output is a kind of overfitting on some features. So a new technique that came, like I think a couple of years ago with all the language models is trying to generate the new data from scratch, basically. There are like some research and interesting results with like just take GPT-3 for ChatGPT or the T5 or BERT or Roberta, and try to make it write down some examples that you don't have in your data set. And we see that for easy tasks such as sentimental analysis, classification, or like binary classification, generally it works pretty well. Like you can balance again your data set and you can train from this synthetic data, and you can reach like state-of-the-art results in the end in this classification. The third one, I would like the other technique I would like to mention, and I think you all heard about it since Stable Diffusion has been out, is like the prompting. I imagine that you have a lot of unlabeled data. I used to work on social networks, so I had like access to a lot, like millions and millions and millions of data, which were unlabeled. And for my classification, it was a problem. So what we did was trying to create some prompts to make the model think about a potential classification of the data. And actually, if you combine it with several prompts, with several models, then you can use weak learning. You can use weak learning strategies to try to add this data, depending on the confidence of your prompts, in your training set. And thanks to that, you can also try to reach the perfectly balanced data set I mentioned first. So, and yeah. And so the last one, which is more experimental, it's related to the one where we go when we dive into the black box, into the model. This is some technique we applied a few months ago, which works pretty well. Large language models, deep learning models, generally they have millions, like hundreds of millions of parameters, now billions of parameters. And the main idea behind that is, okay, in the billions of parameters, maybe not all the parameters are biased. Maybe just some of the parameters, like a few millions or a few thousands, carries the bias in the end, okay? So the main idea would be, okay, let's try to repeat the identification of the issues, of the biases, into the model. So instead of looking at the output, we go into each of the neurons and try to look at the activation of the neurons depending on the inputs. So if I have, like, for instance, a data set with gendered words, I will take a look at which are the neurons that are activated with the word her, or with the word she, and with the word he or him. And actually, if I can identify these little neurons, what I can do is attenuate it into the model directly in post-processing. And what we saw is that the final accuracy, like the global metrics of the model, stays the same, but the difference between metrics for women and men is reduced by a really big margin. Actually, we went from like a 10% difference to a 2% difference on a complaint detector. And finally, I think, so this is not data science, this is more like regulation. But I think if you want to improve the robustness, what you need to do is document all the results that you have, try to identify all the weaknesses in your process. It should be part of the process of development and deployment of your models. And also one other thing I'd like to say, but I know it depends a lot, it depends a lot of the policy of the firm, which is trying to open source the models. Why? Because open sourcing the model can make other people audit the model. So you have other scientists, other data scientists, other project manager that can use your model and try to other use cases. And then they can give you feedback about the results. They can give you feedback about potential flaws that you haven't seen because it wasn't your business. And from that, you will be able to look back directly to the development of your model and try to improve a potential problem in your business. So to conclude, I think, anyway, if you're using like AI system, you're dealing with bias for sure. Even if you don't think about a bias, you always need to think, okay, what could be the impact for any kind of type of population segment? This is something that should be part of the business development. Second, I would say, as I said in the previous slide, you need to be proactive. You need to assess, you need to document, you need to open source if you can, and to document your risk level, to understand what are the risks for your company when you deploy it. And also a few things, a few considerations. The first one would be, there is no universal way to mitigate the bias. Like, there are like some automations in research, but generally each use case has its specificities. So you cannot like just apply one of the methods I showed before and hope that magically it's going to be solved. Generally, it's not like that. And you need data scientists to solve this kind of thing. And finally, I think this is something we don't really focus on, but the biases can totally kill your business. I remember, just a last example, I remember like a firm 3 years ago that claimed they had the best gender detection model, and they put it online and saying, okay, just use it. You see, it's the best gender detector that you may have. And actually, a lot of people were using it and saw that it was unethical as possible because it was overfitted. It has overfitted on a lot of features which were a priori or what's the name? Which were prejudice for women, prejudice for men. And actually, they closed the firm just after that because they were seen as an unethical firm, and it will be really bad for your marketing in the end. Thank you very much.
Thank you, Arnaud. So, do we have any questions? René.
Thank you very much for your interesting talk. I basically have two questions. I start with a more concrete one. Are there any kind of standardized ways to document de-biasing approaches or biasing detection approaches? Like we have like these model cards when we go to Hugging Face or whatever. Is there a way to kind of standardize this? And the other question would be, that's more philosophical. So I think what we think is not a bias today might become a bias tomorrow. So how sure can we be about our de-biasing objectives?
Thank you. So the first question about uniformizing all the bias detection, it's on the road. I would say that, for instance, there are like some firms such as Giscard or I don't remember another one which was focused on regulation, who wants to provide some templates actually to show that your model isn't biased, like to just see all your development flow and show that even if you have some biases, that you tried everything you can to avoid it. I can take a couple of examples on that. I think banks, with like the financial crisis in 28, it was one of the main problem, and they began to have like external audits to be sure that the model has passed a lot of tests. And actually, it's also an old challenge. Like the Turing test, for instance, there are like kind of tests which are made just to see if the models really understand what it's processing. And but the second question was, sorry?
It was about the philosophical thing. So our today's approach to non-biasing might turn out a bias in the future. So how safe or how sure can we be that we're doing the right thing?
Yeah, so yeah, that's a good point. I would say, so obviously we cannot be sure about like the impact maybe of the model in 30 years. So it's always complicated to say, yeah, just deploy it and you'll see. I think you need to prevent any kind of harms that your model may have. The most important would be to have maybe kind of really, how do you say that, opened monitoring, where you can add any test that you can at any moment. Let's say that, okay, so there is this kind of test, because like bias tests, they evolve every day. So let's say we have like a battery of tests that we apply, it passes every test, and tomorrow I have 5 new tests. So the idea would be, okay, can I just add those tests to my new battery and be sure that my model is still working on that? And I think also that's why open source can be like one of the solutions, because you may have like a lot of people testing your model in other ways that you haven't thought about.
Any further questions? One thing I'll add, actually, there's a company that we are working with, Empathy, may be available, maybe may know about them, and they actually are talking about ethical commerce. So obviously dealing with some of these questions as well, so that might also be a future reference. So anyway, Arnaud, thank you so much.